Here's some bit of notation. The inverse of a matrix A is denoted by, we just write A to the negative 1. Now look, this is just a notation. A to the negative 1 is not like you treated variables in algebra. It's not equal to 1 over A. Now, that would mean that, so the inverse of a matrix B is just denoted by that B to the negative 1, or B inverse. What we call this is B inverse, and we call this A inverse. So here's how we can actually find the inverse of a matrix. So if our matrix is A, we want to find A inverse. Now here's how we're going to set this up. We're going to set it up as two matrices like this. We're going to write A on the left, and then a vertical line, and then I on the right. And what we're going to do is go through some row operations like the ones that we used when we solved the systems. Row operations to get, well, as it turns out, if we get I on the left side, automatically on the right side, we will get A inverse. So let's see how that works for this one right here. Let's start it here. So let's go with 1, 3, 2, 5. All right, right here. This is our matrix A on this side. I'm going to draw that vertical line. And then on this side, I'm going to write the 2 by 2 identity. So we're going to have 1, 1, 0, 0, 1. Now, I already have a 1 in this position, so that's our pivot. So I wrote it like that so it would work nicely. Now, what I want to do is get a 0 in this position. So I know how to do this. I'm going to multiply this row 1 by negative 2 and then add it to that row 2. So let's see. Here's how we're going to denote that. Row 2 is going to become negative 2 times the pivot row, row 1, plus row 2. And here's what it looks like. So I'm going to pass that negative 2 through that entire first row. Multiply everything, we'll get negative 2, negative 6, negative 2, and 0, right? I multiplied everything by negative 2. Negative 2 times 1, negative 2. Negative 2 times 3 is a negative 6. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. So let's circle this. And then what we're going to do is add this. Oops. We're going to add this to row 2. So here's our new matrix. First row stays the same. 1, 3, 1, 0. And now let's add. So 2 and negative 2. That's 0. 5 and negative 6 is negative 1. 0 and negative 2 is negative 2. And 1 and 0 is a 1. Okay. Now, we need a 1 in this position. So I'm just going to divide everything here in row 2 by negative 1. So I'll indicate what I'm going to do. So row 2 is going to become the current row 2 divided by negative 1. That looks like this. First row stays the same. 1, 3, vertical line, 1, 0. Dividing by negative 1, we'll get 0, 1, 2, and negative 1. So I've got that 1 in this position now, so that's going to be our pivot. And what we want now is a 0 in this position. So we'll take this opposite, negative 3, multiply it through the pivot row, and then add those together. So here's our plan. Row 1 is going to become negative 3 times row 2 plus row 1. And it's going to look like this. Run that negative 3 right through that second row, multiplying everything by negative 3. We will get 0, negative 3, negative 6, and negative 3 times negative 1 is positive 3. We'll circle that so we don't lose it, and I'm going to add that to row 1. So making that addition, we're going to get this new matrix. We will get 1 plus 0 is 1. What happened here? 1. And then 3 plus negative 3, that's a 0, a vertical line. And then 1 and negative 6 is negative 5. And then 0 and 3 is 3. Now, let's close it off. In our second row, that will stay the same, 0, 1, 2, and negative 1. Now look what we've got here. On this side here, right, on this side, that's just the identity matrix. That's what we were looking to get, our vertical line. And now over here, on the right side, that turns out to be A inverse. Now we got a little bit lucky here. We didn't have any fractions. So let's just claim now A inverse is equal to negative 5, 3, 2, and negative 1. Now, let's circle that. If we've got this right, it really should be that if we multiply A and A inverse together, we should get I. So let's give this a try. Here's our original A right here. Here's what we found with our row operations. We think this is A inverse. So let's see what we get when we do this. A times A to the negative 1 is, we'll get 1, 3, 2, 5. That's A. And then A inverse, we claim it's A inverse, negative 5, 3, 2, negative 1. So this is going to give us, all right, first row, first column, over and down. So let's just do this. 1 times negative 5 is negative 5, plus 3 times 2 is 6. And now, over here, first row, second column, so first and first, second and second. We're going to get 1 times 3 is 3, plus 3 times negative 1 is negative 3. And let's come down now to our second row, first column for this element right here, right? Second row, first column. So we're going to get 2 times negative 5 is negative 10, plus 5 times 2 is plus 10. So negative 10 plus 10, and then finally over here we're going to get second row, second column. So first and first is 6, second is negative 5, so we're going to get 6 plus negative 5, and when we combine these, we'll get 1, 0, 0, 1. Okay, we've got half of it done. Now we just need to show that if you do it the other way, A inverse A, that's also equal to 1, 0, 0, 1. You can try that if you want. It does work. If we want to find the inverse of a 3 by 3, we're going to use the same process. It's just going to be more pencil work. Instead of doing that, why don't we just try this on our calculator? So I found another good website for doing this, and here's what it is. So it's a YouTube site, type in this, and there's a really good example on how to do this. So this is a very nice example of how to use your TI-84 to find the inverse of a 3 by 3, or any size for that matter, should the inverse exist. So if you go to this site right here, you'll see a nice demonstration of how to find the inverse of any size square matrix, should that inverse exist.